Okay, hello everyone. Welcome back to Embedded System course again. So we are in chapter number 2, that is 8051 timers and serial port programming in a C. So we are in part 2. So in previous lecture, that is lecture number 6, we started with second part of this chapter, that is serial port programming of serial port of 8051 in C. Okay, so in the first previous lecture, we studied about basics of serial communication and how to connect serial port of 8051 with RS-232 port, that is serial communication port that is available in PCs and so many other devices. So these 2 points we studied in a previous lecture, and we are going uh, to next point, that is serial port programming now onwards. Okay, so in this lecture number 7, before going to actual serial port programming of 8051, we will see basics of 8051 serial port programming that are uh, required to program serial port of 8051. So under this, we are going to discuss first PC baud rates, then serial communication in 8051, then 8051 serial port baud rate generation, and then we will study the SFRs associated with serial port of 8051. These are SCON and PCON, serial control SFR, okay, and PCON. So first point, PC baud rates. Okay, so baud rate we defined in previous lecture, that is the rate at which serial communication takes place, or simply it is number of times signal changes takes place on communication channel per second. Okay, so that is called as baud rate or bits per second rate. Okay, so to have serial data transfer between 8051 system, okay, that is via serial port of 8051 with other device serial port like personal computers com port or any other device serial communication port. We should make sure that the baud rate of both matches. Okay, means we have to first configure baud rate of 8051 serial port and other device baud rate. Okay, um, and that should match. Okay, if we set baud rate of 8051 serial port X, same baud rate should be set for other device with which 8051 serial port is interfaced, and we want serial communication between these two devices. Okay, so that baud rate of both devices should be matched. Okay, and in case of uh, that is a 8051 interfaced with a PC, then we should follow some standard PC baud rates, okay, with which PC serial port, that is COM port, that is RS-232 port, communicates. Okay, so we should configure 8051 serial port with one of these standard PC baud rates. Okay, because we can configure PC's COM port, that is RS-232 port, with one of these standard baud rates, okay, which are called as PC baud rate. Okay, so these baud rates, standard baud rates, are listed here. So 110 means 110 bits per second, 150, 300, 600, 1200, 2400, 4800, 9600, 19200. So these are standard baud rates supported by 486 or Pentium IBM PCs. Okay, so we should follow these baud rates when we are interfacing 8051 serial port with personal computers RS-232 or COM port. Okay, so this is about standard or PC baud rates. Next point here is UART and USART chips. Okay, so in case of 8051, on chip UART module is available, and that helps us to have asynchronous reception transmission via serial port of 8051, that is in the form of TXD pin and RXD pin. Okay, so in case of 8051, we have that UART module, that is universal asynchronous reception and transmission module on chip. Okay, but there are some specialized chip. Okay, so that are also available, that we can use for serial reception and transmission, and these chips are also called as UART or USART. Okay, so what is difference between UART and USART? So UART is universal asynchronous reception transmission, means only asynchronous type of reception transmission is possible in such models. Okay, and USART means universal synchronous asynchronous reception transmission, means in this you can configure these chips either in synchronous mode or asynchronous mode. Okay, but in case of 8051 we can have only UART, that is asynchronous reception transmission. That is the difference. Okay, so next point, serial port communication in 8051, and that is, as I told you, that is asynchronous serial communication is available. Okay, now this is the block diagram, internal block diagram of serial port of 8051. Okay, so these are TXD and RXD pin. So if I draw here, okay, one line. Okay, so whatever this block diagram, okay, so that is internally inside 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 805. Okay, so so these are the two pins, TXG, that is pin number 1 of port 3, and RXD, that is the pin number 0 of port 3. So RXD means this pin is used to receive data serially, and TXD means this pin is used to transmit data serially. Okay, so these two pins are nothing but serial port of 805. Okay, so internally there is a such a uh, such diagram is there. Okay, if we draw block diagram of serial port, okay, that is inside 8051, so we can draw that diagram like this. Okay, now see here, this is a internal bus of 8051. Okay, and if we want to transmit or receive data, okay, serially, we have to make use of this 8051 internal bus, because it is connected to this uh, serial port circuit. Okay, so suppose if we want to transmit data, okay, so for example, for that there is one SFR. Okay, so that is a SBUF SFR, serial buffer SFR. So if you want to transmit some data, okay, so obviously we will transmit it in chunks of 8 bits, because in case of asynchronous serial communication, okay, one byte or one character will be transmitted at a time. Okay, so that character or byte to be transmitted, that should be written into SBUF. Okay, so that will be written into SBUF. Okay, uh, which is the internal SFR. Okay, and this SFR we cannot access via uh, 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 that is explicitly. Okay, so it is used only in serial communication. We have to use this SBUF only in case of serial communication. Okay, so if you see, here is SBUF and there is one more SBUF. Okay, so while serial transmission, this SBUF will be referred. Okay, and while reception, this SBUF will be referred. So actually SBUF means there are actually two SFRs. Okay, one is used during transmission of data and other is used while reception of data. Okay, so while transmission SBUF, that is the write only, means we can write only in this SBUF, and this SBUF that is used while reception, we can read only. Okay, for example, suppose we are transmitting data serially, so that one byte of data that we want to transmit, that should be written into SBUF first. Okay, so once that one byte of data is written into SBUF, Okay, so that will get framed in between start bit and stop bit. Okay, so total number of bits will be now 10 bits. Okay, because if we assume one start bit and one stop bit, okay, so this one byte means 8 bits and this start bit and stop bit means 2 bits. So total 10 bits of data will be shifted on this TXD pin. Okay, with the baud rate or data rate selected by us. Okay, with that rate that these 10 bits will get shifted. Okay, so that will be decided, that baud rate will be decided by the clock supply to this SBUF. Okay, so that will decide the rate with which these 10 bits of data will be shifted out on this TXT pin. Okay, so this part we will study later, how to set that baud rate. Okay, means how to set this baud rate clock. Okay, uh, so this is a transmission part. um, Reception part, again, the rate of reception will be decided by baud rate clock. Okay, that we will see later. So this RxD pin acts as input. Okay, via this pin the serial data will be received. Okay, and it is shift register. Okay, means these bits, okay, will be shifted, and it is of 8 bits. Okay, so first what will happen? So while reception, out of 10 bits, okay, in which first will be start bit, then 8 bits of data, and last will be stop bit. Okay, so out of these 10 bits, data bits will get separated and that will be kept in the shift register. Okay, so one bit at a time that will get received and that data will get shifted into the shift register. After receiving all data bits, that is 8 bits of data. Okay, so that data will get moved automatically into this SBUF of this reception part. Okay, serial buffer register, and that is read only. We can only read this SBUF. Okay, so once 8 bits of data gets received in SBUF, okay, so that can be shifted, okay, or that can be moved inside 8051 to some safe place like internal registers. Okay, so that this SBUF will be empty and it will receive the next byte. Okay, that is being received by this reception part of this serial port. Okay, so one more thing is there. Whenever we write one byte of data into SBUF to transmit it serially via this TXT pin. Okay, once we write that one byte of data, transmission begins. Okay, and when transmission of all these uh, 10 bits of data, okay, that is start bit, 8 bits of data, and stop bit completes, then there is a one uh, that is a flag bit, that is TI, that is called as transmit interrupt, that will get set, indicating that transmission of this one byte of data is completed. Similarly, while reception, when uh, 8 bits of data is received, that is one byte or one character of data is successfully received, and that is available in this SBUF register of this reception module. Okay, then there is one flag bit, that is RI. Okay, that is a receive interrupt flag bit, that will get set, so that user can um, user can move that data bits available, or 8 bits of data available to some safe place, so that it will not get overwritten by next byte, okay, being received. Okay, so these are called TI and RIs are called as interrupt flag bit. Okay, TI is called as transmit interrupt, RI is called as receive interrupt. So these interrupts should be monitored while programming serial port for transmission and reception of data. Okay, so this is the internal diagram of serial port of 8051. uh, so SBUF is an 8-bit register used in serial communication. For a byte of data to be transferred via TXD line, it must be placed in SBUF. SBUF holds the byte of data when it received by 8051 RxD line. So that is what I just told you. So let us move. Next part is 8051 serial port baud rate generation. Okay. Okay, so we can select baud rate, means the rate with which we want to transmit or receive data. Okay, through or via serial port of 8051, that we can configure. Okay, so to set the baud rate of serial port, okay, of 8051, timer 1 is used. Okay, and it is used in mode 2, and that is 8-bit auto reload mode. Okay, so in that case, th1 should be loaded with proper initial value, okay, to generate the standard baud rate. Okay, and in that case, okay, if we want to generate standard baud rate, then the oscillator connected to 8051, that should be of 11.0592 megahertz. That is mandatory if you want to generate standard baud rate. Okay, that is these baud rates, then we have to use this oscillator frequency, that is 11.0592 megahertz. Okay, now to set one of the standard baud rate, what we have to do, we have to load this th1 with some proper initial value. And how to determine that proper initial value? For that, we have to check the block diagram, okay, of that is uh, baud rate clock that is generated internally. Okay, so that is shown in this diagram, this baud rate clock, okay, that is generated. Okay, so that is same for this transmission and reception module. How that baud rate clock is generated, that we need to know. Okay, so that baud rate clock is generated, and that is here 28800 hertz. Okay, so we are assuming that we have used F oscillator. So this is F oscillator. F oscillator is 11.0592 megahertz. Okay. So as I told you, to generate standard baud rates, we have to use F oscillator equal to 11.0592 megahertz. Means whatever crystal oscillator we have to use in our system, that should be of 11.0592 megahertz. Okay. So here I am getting clock pulses of frequency what, that is 11.0592 megahertz. Internally it will get divided by 12. Okay, so here I will get F oscillator divided by 12, and that is equal to 921.6 kilohertz. Okay, further whatever serial port inside 8051, okay, that is we can also call it as UART module, that is universal asynchronous reception transmission module, that is nothing but serial port of 8051. So internally that frequency, that is F oscillator divided by 12, that is further divided by 32. Okay, and in this way we are getting, so if we divide this 92.6 kilohertz by 32 again, I am getting 28800 hertz. Okay, that is 28.8 kilohertz uh, pulses. Okay, and that act as baud rate clock. Okay, so this is called as baud rate clock, equal to 28800 hertz. Okay, so now this frequency acts as timer 1 clock frequency, means this is supplied to timer 1 further. Okay, so I will draw here, this is supplied to timer 1, timer 1. Okay, so let us draw it properly. So suppose, so this is, okay, so timer one is used. So this is a 28800 hertz frequency, which is acting as timer 1 clock frequency, and timer 1 is configured in what, that is 8-bit auto reload mode, that is mode 2. Okay, so we will load some value in th1, and that will get automatically reloaded into tl1. Okay, whatever value we will load in th1, that will get copied into TL1. Okay, and whenever count in TL1 rollovers from all ones, that is FF to 00, what will happen? It will set TF1 flag bit. Okay, so here see, if we load, suppose, okay, so -3, if we load -3 into th1, okay, -3 means what? Actually 2's complement of -3 will get loaded into th1. Okay, that is fd. If we load fd into th1, what will happen? So same value fd will get copied into tl1 fd. Okay, now what will happen? Due to these pulses, when we turn on timer 1, what will happen? These pulses will start reaching to this timer 1 register, which is configured in mode 2, that is mode 2, that is 8-bit auto reload. Okay, so count in TL1 will start incrementing. Okay, now see here, when this TL1, okay, will roll over from all ones to all zeros, so fd, so due to first pulse, okay, so due to this first pulse, what will happen? Count will be fe, count will get incremented by 1. Okay, then due to next pulse, what will happen? Count again will get incremented by 1 ff, and due to one more pulse, that count rollovers from ff to 00. Okay, means due to 3 pulses, okay, of this 28800 hertz, what will happen? Count in TL1 will roll over from all ones to all zeros, means initially this TF1 flag bit is 0. Okay, and then it will set, then it will set. Okay, so one pulse gets generated after 3 pulses at the input. Okay, so similarly, again what will happen? Again this when TF1 flag bit will get set, okay, that causes to again reloading of value in TH1 in TL1, means TL1 again gets loaded with value FD. Okay, and after that, again due to 3 more pulses, what will happen? Count in TL1 again rollovers from um, all ones to all zeros, that is ff to 00. Okay, means again after 3 pulses, again this tf1 flag bit will get set, and that will get generate 1 pulse. Okay, so what is the rate of generation of this pulse? After three pulses of frequency 28800 hertz. Okay, means whatever pulses that I am getting at the output, okay, at the output here, that is tf1 flag bit. Okay, so the rate of generation of these pulses, okay, is exactly, we are getting 1 pulse for 3 pulses of 28800 hertz. Okay, means this is simply dividing. If we load th1 with fd, what is happening? This 28800 frequency is just dividing, 28800 is just dividing by 3, means actually I am getting frequency of 9600 hertz, and that is these pulses are acting as, that is baud rate clock. Okay, baud rate clock. Okay, so these pulses are used um, to supply baud rate clock in this diagram. Okay, baud rate clock. Okay, so that means here if we load value fd into th1, then what baud rate clock frequency will be? It will be 9600. If we load fa, that is -6, that is fa, what will be baud rate frequency? It will be 4800. If we load f4, then what will be the baud rate clock frequency? 2400. And if it is e8, what is the baud rate clock frequency? 1200. And this baud rate clock frequency determines the baud rate. Okay, means if we say baud rate frequency is 9600 hertz, means its baud rate is 9600 bps, that is bits per second. Okay, that is the meaning. In this way, by loading proper value into th1, okay, that is a timer 1 register th1, we can set a particular baud rate, particular standard baud rate, okay, of for the serial port of 8051, and with that the data will be shifted or transmitted, or data will be received. Okay, because that will, here this baud rate clock, if it is 9600, means whatever byte we have loaded into sbuf, okay, that will be shifted on this txd, means will be serially transmitted on this txd pin with the rate of 9600 bits per second. That is the meaning. Okay, so in this way we can set baud rate. Okay, so for that example is given. Okay, for example, with whatever we discussed, that is written here. With crystal frequency 11.0592 megahertz, find the th1 value needed to have the following baud rates: 9600, 2400, 1200. So the solution is the machine cycle frequency, that is equal to, that is f oscillator divided by 12, that is 9216 kilohertz, and further it is divided by UART, internal UART, that is the serial port circuitry of 8051, by 32, and we are getting 28800 hertz frequency by UART. Okay, and it will be used as timer 1 clock frequency. Okay, and if th1 is loaded with value minus 3, that is FD. If th1 is loaded with FD, then I will get baud rate 9600. If th1 is loaded with f4, that is minus 12, then I will get baud rate 2400. If I load th1 with e8, that is minus 24, then I will get baud rate 1200. Okay, so in this way I can. Okay, so in this way, by loading th1, that is timer 1 higher order register, we can set a particular baud rate. Okay, so timer 1 should be used in mode 2, that is 8 bit auto reload mode. Okay, and then by loading proper value into th1, we can set a baud rate like this. Okay, okay, now we will move to next point, that is SFRs of serial port of 8051. So there are two SFRs associated with serial port of 8051, SCON and PCON. Okay, so uh, serial port operation is controlled by these two SFRs, SCON and PCON. So SCON is nothing but serial port control SFR. By using SCON, we can configure and we can see status of data transmission and reception. Means we can configure serial port of 8051 by using this SCON, and we can also get status of data transmission and reception by using this SCON. Okay, so we can program for the start bit, stop bit, data bits of data framing, etc. by using this SCON, that is configuration. Okay, and status of data transmission reception means whether the data byte that is loaded into SBUF is completely transmitted or not, or whether a byte is received and that is available in SBUF or not. That can be checked by using a particular bits of this SCON. How? That we are going to study. Another SFR, that is PCON, that is power mode control SFR, and out of this PCON only D7 bit is of use. Okay, for serial port programming, and that is bit number D7, which is S mod, and that is used to just modify baud rate. Okay, by setting this bit we can double baud rate of serial communication. Okay, so if this bit is 0, so normally according to whatever calculation we are getting baud rate, that will be the baud rate. But if we set this bit, what will happen? So baud rate will get just double. Okay, so in previously if it was 2400, if we set s mod bit, I will get baud rate 4800 bits per second. That is how we are going to study. So first we will see SCON. So this is a format of SCON, serial port control SFR. So SM0, SM1, SM2. So D7, D6 and D5, these bits are used to configure serial port in various modes. REN bit, that is D4 bit, is REN, that is receive enable. So to receive data serially, we have to make this bit 1. TB8 and RB8. TB8 means transmit bit 8, and RB8 means receive bit 8. So these two bits are used when we are using 9-bit UART mode. Okay, TI and RI bits are status bits. We have to read these bits. Okay. TI means transmit interrupt flag. RI means receive interrupt flag. Okay. So TI bit normally 0, and it will get set when transmission of 1 byte completes. Okay. And RI bit normally 0, and when this receive interrupt bit sets when reception of a byte is completed, and if that byte is available in SBUF, then RI flag bit will get set. Okay, so TI and RI collectively is also called as interrupt serial port interrupt. Okay, so SM0, SM1, SM2, so serial mode specifier. Normally SM0 and SM2 bits are used to configure serial port, and SM2 is used for multiprocessor communication. That means um, if in your embedded system, if you are using more than one microcontroller, okay, in that case this SM2 bit is used. Then REN, as I told you, it can be set or cleared by us through software or program, and this is used to enable or disable reception. Okay, TB8 and RB8 are used when we are using 8-bit UART mode. Okay, we will see TI-RI as we discussed. So SM0, SM1 and modes are given. So if this SM0 and SM1 means this D7, D6 bits, these are 00, that means mode 1. Mode 1 is what? Shift register, means simply whatever byte you load in SBUF register, that will serially shifted with frequency, oscillator frequency divided by 12. That is with the rate of F oscillator divided by 12. Whatever byte you have loaded into SBUF, that will get shifted on TXTP. That is the mode 0, that is shift register mode. Okay, so it is called as shift register because when we are using mode 0, okay, so 1 byte of data that you want to transmit, that will not get framed in between start bit and stop bit. Okay, means that is when you are using mode 0, means that is not a serial communication or asynchronous serial communication. It is just called as shift register because whatever byte you want to transmit, that will not get framed in between start bit and stop bit. That is the meaning. Then if you make SM0, SM1 bits 01, means we are configuring serial port of 8051 in mode 1, and this mode 1 is called as 8-bit UART mode. Okay, so 8-bit UART means 8-bit universal asynchronous reception transmission, means in this mode 8 bits of data can be transmitted at a time. That is 1 byte of data will be transmitted at a time, and to transmit that 8 bits of data, one start bit and one stop bits are used. Okay, and then it is called as asynchronous reception transmission. Okay, means we can also receive 8 bits of data. Okay, we can transmit or receive 8 bits of data by using this UART. Okay, so in that case we can set a particular baud rate. Okay, by using timer 1. Okay, by loading proper value in th1 of timer 1, we can set a particular baud rate. So this mode 1 is called as 8-bit UART with variable baud rate. Okay, then if we make SM0, SM1 bits 10, that is called as mode 2. Okay, which is 9-bit UART, means 9 bits of data can be transmitted or received. Okay, by framing it in between start bit and stop bit, so that total number of bits will be 11 now. Okay, because here 9 bits of data we can transmit, one more bit we can transmit. Okay, in this mode 2. Okay, and as we know, we can load only 8 bits of data in SBUF. Okay, so in that case, in mode 2, that is 9-bit UART. Okay, while reception and transmission, the extra bit. Okay, so for that 2 bits from this SCON are used, that is TB8 and RB8. While transmission, that 9th bit we should load into TB8 bit. Okay, and in reception, while receiving these 9 bits of data, 9th bit will get loaded into RB8, that is D8 bit. D0 to D7 bits will be available in SBUF, and D8 bit will be available in this RB8 bit. Okay, so these TB8 and RB8 bits are used in only mode 2 and mode 3. Mode 2 is 9-bit UART with fixed baud rate, that is either F oscillator divided by 12 divided by 32 or F oscillator divided by 12 divided by 64. or it is directly given probably, that is baud rate will be equal to f oscillator divided by 32 or f oscillator divided by 64. Okay, so that is already that 12 factor is included into this. Okay, so either of these two baud rates is possible in this mode 2, that is 9 bit UART. Okay, so it is called as fixed baud rate. Okay, that is either f oscillator divided by 32 or f oscillator divided by 64, and it depends on whether that s, that is which bit, that is s mod bit from pcon. If this bit is reset, means 0, I will get baud rate f oscillator divided by 32. If that bit is set, I will get baud rate double, that is f oscillator divided by 62. That is the meaning. And last mode, that is mode 3, we can configure if sm0 sm1 bits are 1 1, and that is called as 9 bit UART variable baud rate. Okay, means I can use timer 1 to set a particular standard baud rate. In that case, if standard frequency, oscillator frequency, that is 11.0592 megahertz is used. Okay, so same format is given here, only in this format this tb8 tb rb8 bits are not explained, but here these bits are explained. tb8 rb8, that is tb8 is transmit bit 8, that is the ninth bit transmitted in modes. Okay, 3, and set, it is set and cleared by software. And rb8, that is receive bit 8. Okay, that is the ninth bit received. So these two bits are used in mode 2 and mode 3. Okay, so for that illustration, this format is given. Okay, so this is about scon format. Okay, so we can configure these sm0 sm1 bits to select a particular mode of serial transmission reception. One of these modes we can select, but we are going to concentrate only on this 8 bit UART. Okay, because this shift register mode, that is not actually serial transmission or reception. It is just shifting whatever byte we are going to load into sbuf on txt pin. Okay, so that means it is not framing data bits in between start bit and stop bit, so that is not real serial communication. Okay, so what is real serial communication? So remaining three modes, mode 1, mode 2, mode 3, are actually universal asynchronous reception transmitted transmission serial communication. Okay, so out of these three modes, we are going to concentrate only on this mode 1, because this 9 bit UART mode not necessary to study. We are not going to use 9 bits of data for transmission. We are going to use only 8 bits of data for transmission, or we are going to receive 8 bits of data. Um, so we are going to concentrate our study on mode 1, serial mode, serial port mode 1, that is 8 bit UART with variable baud rate, and that baud rate we can set by using timer 1, which should be configured in mode 2, that is 8 bit auto reload mode. Okay, so second SFR that is associated with serial port is pcon, but only one bit of from this pcon is used, that is D7 bit. Okay, that is S mod, and that is used to modify baud rate. If this bit is 0, normally whatever baud rate that baud rate will get generated, and if we set this bit, okay, so whatever normal baud rate, that will get doubled. Okay, how that we are going to study. Okay, so in this way, in this lecture, we discussed about basics of 8051 serial port programming. Under that, first we saw what are standard baud rates, that are also called as PC baud rates. Okay, so these are like this 110, ranges from 110 to 19200. These are standard baud rates. Okay, so uh, these are also called as PC baud rates. So we should configure 8051 serial port uh, with one of these baud rates if we want to have communication of our 8051 serial port with PCs RS232 or communication port. Okay, then we will saw serial communication in 8051 internal diagram of serial port. Okay, so there are transmission part and reception part. Okay, so how these 8 bits of data that is loaded into SBUF, that will get transmitted via this TXT pin, and how 8 bits of data, okay, received via this RxT and will shifted into the shift register, and then once all 8 bits of data received, it will get moved into SBUF. Okay, and that further can be moved to any other register of 8051. Okay, so we thus saw the importance of SBUF. So the rate with which transmission and reception takes place, that will be derived by this baud rate clock. Okay, and how that baud rate clock will be generated? It will be generated from F oscillator, that is crystal connected to 8051. Normally, if we want to generate standard baud rate, this F oscillator should be 11.0592 megahertz, which is further divided by 12, and it is further divided by 32, and that frequency will be used to set the uh, that is baud rate clock. Okay, so that is here, that will be baud rate clock, that is equal to 28800 hertz by default, but that you can change. So that you can modify it to a particular standard baud rate by loading proper value into th1. Okay, if you load th1 with fd or -3, okay, then we will that 28800 hertz further will get divided by 3, and we will get baud rate 9600. If we load -6 or fa into th1, that 28800 will get divided by 6, and we will get baud rate 4800, and so on. In this way we can set a particular baud rate of serial port of 8051. Okay, so then we saw um, SFRs of 8051 serial port, SCON and PCON, to configure uh, serial port of 805. Okay, so we saw modes. Okay, depending on whether SM0 and SM1 bits are set or reset, there are four modes: 0, 1, 2, 3. Out of these four modes, we are going to focus our study on this mode 1, that is 8-bit UART, which is 8-bit UART variable baud rate mode. Okay, so and picon, only one bit, that is d7 bit of picon is used to double baud rate. Okay, so details we will see in next lecture. Okay, so this is about basics of serial port of 8051. So we will continue in next lecture, that is serial port programming. Okay, so any doubts we can discuss in our live session. Okay, so I will stop here. Thank you.